In this section on standard deviation, our goal is to be able to, given data, calculate and interpret standard deviation and distinguish it from mean absolute deviation. We'll be able to explain ways in which standard deviation addresses dispersion differently than box and whisker plots. Let's take a look at this situation. Number 1, each of these data sets has a mean of 20. Order the sets from greatest standard deviation to least standard deviation. So greatest means big, least means small. So when it says order, we want to write them from big to small. But that means we need to know how to calculate standard deviation. Well, what is standard deviation? That's a statistic that measures the spread of the data away from the mean. And that's really important that we know that it's away from the mean. Box and whisker plots measure with respect to the median, but standard deviation measures with respect to the mean. There's another type of measurement that does that called the mean absolute deviation. That's another method of calculating deviation from the mean. But today we're going to focus on standard deviation. Let's look at this example. Use your calculator to find the mean and the standard deviation of the following data set. Let's go to the calculator. Remember how we type it in, stat, edit, and then we type in our list. 1, enter, 2, enter, 3, enter, and so on and so forth. When we're finished entering our list, we'll go to Stat, Calc, and choose the first selection. We may have to press enter a few times to see our results. Remember that X bar is the mean, also called mu, that's 5.5, and the standard deviation is sigma, that's 2.5. So X bar, or mu, we said 5.5, and the standard deviation, sigma, 2.5. Highlight this. Remember that the standard deviation in the calculator is represented by the sigma symbol. And again, a review of your calculator instructions. Stat 1, and then enter the values in the list, and then stat, arrow over to calc, and press enter. Map the data set on this number line. To map the data set are these points right here. This is the data set. To map it on the number line, we're going to plot these points. Where is 1? I find it, I plot the point. 2, I find it, I plot the point. 3, plot the point. 4, 4, 4, I can only put that in one spot. 5, 6, 7, 8, and 9 are the next ones. 5, 6, 7, 8, and 9. Now I'm going to mark the mean. The mean is 5.5. I'm going to find, here's 5, so 5.5 is right here, and I'm going to mark mu for the mean, and I'm going to mark the standard deviation, 2.5. So 2.5 standard deviation means I'm taking the mean, which is 5.5, and I'm adding the standard deviation. One standard deviation gives me 8. So one standard deviation away is at 2.5 units away. That's right here. This is plus 1 standard deviation away. I can take 8 and I can add another standard deviation. That makes 10.5. So I'm going out to 10 and a half. That's plus 2 standard deviations. And I can do it again. Take the result, 10.5, add another standard deviation. That makes 13. 12, 13, here is plus 3 standard deviations. See, I've added it once, I've added it twice, and I've added a third standard deviation. I can also find the standard deviations to the left of the mean. So I'm going to start at the mean, 5.5, and I'm going to subtract the standard deviation, 2.5. Subtracting gives me 3. So go down to 3. This is minus 1 standard deviation. Take where I left off, subtract another standard deviation. That gives me 0.5. Minus 2 standard deviations. Take where I left off, subtract a third standard deviation. That takes me to negative 2. Negative 2 is where I have minus 3 standard deviations. So again, to get out here, I subtracted a standard deviation once, subtract a second time, subtract a third time. I can subtract the standard deviations to go below the mean. I can add the standard deviations to go above the mean. Let's answer some questions that are related to the graph that we mapped. Which values in the data set are within one standard deviation of the mean? So I'm looking at out one standard deviation above and one standard deviation below. If it says within, I'm looking in that area right there, within. So I'm looking at where I've plotted points. I see a point at 3, 4, 5, 6, 7, and 8. So which values? 3, 4, 5, 6, 7, and 8. Only using the points that I've plotted. Which values are between plus 1 standard deviation and plus 2 standard deviations? Now I'm looking between plus 1 sigma and plus 2 sigma. Here's plus 1 sigma and plus 2 sigma between. Between means I don't include what is on the line. I include just what's in between. I only have a point at 9, not at 10, so 9 is the only value that is between. Which values are between negative 1 and negative 2 standard deviations of the mean? Now I look here, negative 1 to negative 2, between is right here. That's going to be just these two, 2 and 1. Which values are more than 2 standard deviations away from the mean? So more than 2 standard deviations. I find 2 standard deviations and I'm going more than. I have no values out here that are more than 2 standard deviations. But what about more than 2 standard deviations below the mean? Here's negative 2. I'm looking here. I don't see any away from the mean under 2 standard deviations below the mean. So none. Anything that is more than 2 standard deviations away, these are called unusual. Unusual. Anything that is within 2 standard deviations, so from here to here, these are called usual. Usual is between negative 2 and positive 2 standard deviations. Unusual is more than 2 standard deviations away from the mean. How many values are below the mean? So this time it's asking me to count how many. So I'm going to count the number of points that I see on my number line below the mean. Here's the mean. I see 1, 2, 3, 4, 5. There are 5 values below the mean. Let's use standard deviation in situation number 2. The mean temperature The mean temperature over the past 100 years for the first day in June in the city of Eyebrow, Kentucky is 89.5 degrees with a standard deviation of 6.5 degrees. Find the temperature that is 2 standard deviations below the mean. So I see the mean is 89.5. Let's write that down to take it out of the words, out of the paragraph. Standard deviation is 6.5. Find the temperature that is 2 standard deviations below. Below tells me to subtract. So I'm going to start with the mean, 89.5, and I'm going to subtract 1 standard deviation, and let's see what that gives me, 83. But I want to go below by 2 standard deviations. So I'm going to subtract again. And I get 76.5. So my answer is 76.5 degrees. I can also look at it like a number line. I like to put the mean in the middle. The mean is 89.5. 89.5. And I go down by 6.5. 1 standard deviation is here. Subtract it once. That leaves me at 83. Go down again, minus 2 standard deviations. That takes me to 76.5. This is below the mean. This is above the mean. Situation 3. The average bottle of ketchup weighs 567 grams with a standard deviation of 5.5 grams. So the average is 567, the standard deviation is 5.5. How many standard deviations above the average bottle is a bottle that weighs 586 grams? How many standard deviations above? So what I can do is I can take 567. If it says above, that means I'm going to add the standard deviations. So I add 5.5, add 5.5, and I get 572.5. I'm not quite to 586, so I'm going to do it again. Add 5.5, and I get 578. Not there yet, so let's take 578 and do it again. Add 5.5, and I get 583. I'm not there yet, so I add 5.5, and I get 589. Now I'm over 586. So it took me 1, 2, 3, and a little bit more to get over 586. Well, notice that 586 is between 583 and 589. So it actually takes 3, 1, 2, 3, and half of a standard deviation to get to 586. Is this a usual or unusual weight for a bottle of ketchup? Explain. This is more than 2 standard deviations away, so this is unusual. Unusual because 586 is more than 2 standard deviations from the mean.
Now let's go back to situation 1. Now that we've worked with standard deviation a little bit, and we understand that it measures the spread of the data away from the mean, how much the data is spread, how far apart it is. So looking at each set of data, notice that set 2 are all the same numbers. So this has the smallest spread. This would be the smallest standard deviation. Which one has the most spread? Well, look at this one. The smallest number is 18. The biggest number is 22. From 18 to 22, that's only 4 units apart. In this one, the smallest number is 16. The biggest number is 25. That's only a difference of 9 units apart. That's more than 4 units apart. So this one has the biggest spread, or the biggest standard deviation. So if we're ordering from big to small, we don't even have to calculate these standard deviations. We see that the biggest spread is set number 3. The next biggest spread is set number 1. And then finally, the smallest spread, where there's no difference in any of the numbers, is set number 2. Take a couple of minutes to write a short summary. Compare and contrast box and whisker plots and standard deviation. See you in class!